With FDM, we are working with true engineered thermoplastics, so we can literally test the mechanical properties of the part.
The FDM process is we take filament, heat it up so it's soft, and then lay it in layers to create parts. When a part comes in from a customer and we're quoting it, we look at like what its fit, form, and function is, and that helps us to decide materials. Do they need more strength? Is it just a prototype? And that some of the materials are better for just prototypes that are quick and easy to make, where some of the materials are a little bit stronger, so you need the strength for the part depending on if it's taking a weight load or anything.
We work with our customers very closely to try and decide what the end item function of the parts that they're going to be using, and then we can recommend what material would work the best for their application. We have 8 FDM printers in-house. They are all manufactured by a company called Stratasys.
Our larger printers and the Fortis machines can run multiple types of materials with multiple slice heights for strength and for different purposes, whereas some of the smaller machines can only run ABS, and those are good for just quick prototypes and the turnaround there.
We use additive manufacturing to prove that that is the tool that's the part that's exactly going to fit what we're doing. Then we'll go make a tool string, and it might go to additive manufacturing, or it might even go to subtractive. You know, if you really prove it with additive, then you decide what's the best, cheapest, fastest way to mass produce it.